information. They might be afraid of not answering their questions on my mailing list, but anyhow, I'm glad that you found the talks interesting to the final. So yeah, asynchronous processing in Kamailio configuration file, going quickly, faster than you think. So what we try to solve was the issue, trying to avoid blocking operations. Why? Increase the performance. So yeah, performance issue, because you guys, they don't have it, so we got that. Thank you.
Thank you.
Questions? Anyhow, it's not about Kamailio then, let's spend a bit of more time. So what's now quite critical in terms of performance with Kamailio, because CPU it's fast, you can add more cores, you have memory, what impacts the performance is. So the most used one would be database, where you'll have like blocking operation to read, write to the database. And here, and in general, could be two types of situation when you need to wait for the feedback, or you don't really care that much from the point of view of SIB routing. So sometimes you need to wait for the result anyhow, and sometimes you want to delegate to a let's say secure or safe way to write into a database, but you as SIB router, you want to take care of keep routing SIB packets. The second one would be DNS, and unfortunately is not that much used, but when it's used and is not available, then nothing is working. The well-known saying of if DNS is down, internet is down. And we would like to see it more and more in voice over IP and especially interconnect as well, because it will make our life easier for high availability if the devices and other application signators will implement proper DNS. And then interaction with other external system, rating engine, billing system, this prepaid system are also critical part of voice over IP platform, telephony and real-time communication platforms. So making a step back to understand our architecture and how you could go around all these blocking situations. We are a multi-process application. That means we spawn a bunch of processes, sometimes could be many of them depending on how many modules you are using, how many sockets you are listening on. And typically we have so-called SIP workers which deal with routing SIP packets. We have called the main attendant, which is just like the father of all the processes and supervising. It's not doing anything at runtime, and that's really great because cannot crash. If one of the children crashes, then it takes care of cleaning the memory, like synchronizing with the database and taking care of a night shutdown, even if it's a situation of this kind of crash. TCP attendant, it's the one that takes care of distributing the load on TCP connection in terms of accepting connection and then delegating to another SIP worker to handle the traffic on it. And then we have per type of transport leg, UDP and SCTP, another pool of processes. TLS being in top of TCP is practically the same pool of processes that we are using. Then some dedicated modules for control interface like FIFO receiver, data rate, and XML. Then another group of special processes will be the timers, and from SIP needs we have the SIP retransmission timers. But then there are some dedicated timers, and sometimes we can use these ones, and you will see in some examples using these custom timers for doing some asynchronous processing. And special handling, and I'll speak about this event API new module where we spawn a new process just for getting the callbacks on this event library. So we could do two types of delegation of blocking operation. As we are a multi-process application, we have these SIP workers, and we don't want to block them. It might be an invite that has to do a DNS query, and you can detect that we have IP ops module, and you can see the request URI, it's a DNS host name, so you expect then it's gonna block. So you can delegate it to another process, which will do simply relay, because the relay will do DNS query. But the other process, which is dedicated for handling SIP, can get register, which stops there, can get subscribe, can get a buy, which goes via record route. So this one, it's handling all the traffic that doesn't really involve DNS. Probably you're aware, like last year or 2 years ago, more or less, when GoDaddy was down, pretty much a lot of troubles in blocking on, especially North American operators, because they are using it. This is delegation of the task in Kamailio, the same instance, but then you can do it in between instances. So you have the traffic. I put the example here with the users, calling them, and then we have another dedicated instance, and you can use it as an example and for delegating this blocking operation. Here you could wait for a response before sending out, or maybe you don't care about that. I'll have 3 examples trying to fit into the time with these use cases and trying to combine all the modules that you could use in Kamailio. So what are the basic components in Kamailio? So back to these cases, just to refresh them again, it's impacting SIP router. So yes, it's blocking, but without the result, I cannot go on. So like a DNS query or whatsoever. Not impacting SIP routing, maybe then we can push it to another process that will do the task, and we just go on with the normal routing. So these are the components we have, and you could combine them for doing asynchronous processing. TNX, which stands for Transaction Management Extensions, exports to the configuration file the function that allows you to suspend the processing of a request and response, thanks to a latency list addition from the guys at Smile Telecom in South Africa. So now we do asynchronous processing for requests and responses. So you get a request, you can park it somewhere in memory, then you can handle all other SIP requests coming on your socket as a process, and triggered by an event, you will resume that request or response and will continue routing that message. Then we have UAC, User Agent Client module, which is good for sending custom SIP messages from the config file. So we have invite, but then we want to generate another request, a new one from scratch. Could be related, like taking some information from the invite, but could be something unrelated, taking information from the environment, and you send it to another instance, and then practically you can delegate that task to another instance. Async module was added mainly to give an example of how to use this suspend result of SIP transactions. So it exports now asynchronous execution of a routing block. So you can say execute this route block after 1 second, or it's up to you to decide the interval. The normal process will handle the SIP traffic that is keep coming on the socket, and another worker that is created by the asynchronous module, which has a pool of another processes just for this asynchronous execution. Will
Would you die?
Sorry?
Nick is dead.
The Nick is dead. Probably I can take this turn. While we're dancing. Now it's good? Okay. So, back to the async module. Asynchronous execution of a routing block with all these actions in that routing block, and another one, asynchronous sleep. So we'll sleep and we'll continue with the next action after the asynchronous sleep, and with some limitation there, because we have to save the state of the interpreter, and we have those information in the reading. Then we have the message queue, which allows you to communicate between the processes of the same instance of Kamailio, so from the SIP. routing process, you can send to another process some information, they will read it and they will act on that. Our timer gives you the possibility to start from the config file. Another process is that could check on an interval base as you define it. It's microsecond affinity with the latest version. So eventually the R timer module could check every millisecond if it's something in a message queue, and if it is, will keep consuming. So if the message queue is busy, it will never sleep. But when it's nothing to do, it will sleep for a millisecond. Then something that embed asynchronous processing inside it. It's already there for many releases. JSON RPC client, see? You can do JSON RPC request and will wait for the response, but meanwhile the transaction will be suspended, so the process will handle other SIP messages coming to the socket. And now we have this AV API, so event API, where you can send custom messages from a configuration file. Alex was asking, practically the format could be anything. You could give here the entire event content, and the clients will have to connect to Kamailio on a special port that you configure as module parameter. So this is on the way of integrating with CG rates. It's one of the first applications we want to have it done for this one, but could be used for anything. And we would like to do it a bit more embedded in some modules, so you don't really have to do it always from the configuration file. So examples now. Probably this is one very interesting for everyone using mobiles, where you would like to do push notification. Imagine this, you have an invite coming in, and then the destination, the target user is not registered because the cell phones are going, the smartphones go to sleep and they are unregistered. So the idea is, okay, we get an invite, we look if we have a registration for that user. If not, we do a push notification. When we get the register, we'll resume the processing of the invite request. So practically I have here the difference, or not the entire difference, but the main difference is to the default configuration file. We'll use hash table module to store the ID of the transaction that we suspend. So as you go in the default config file, you have this main request route, and the last call will be route location. Before going to location, we will call this push asynchronous, and we'll do it if needed. When we have a register job to do, so when it is, practically this is the standard one. After saving to the location, we will check if we have a push to join. So it's the order of the config file routing blocks, and mine are at the end. So this is practically what we added to this route block, only this line. The rest is in the default config file. Sending, this is just a more like a prototype, but you will have to see how you do the push notification. You will have to integrate with some APIs. We have been using some Lua script to do it via some HTTP requests, but this you will have to implement it to be specific to your environment. It's just sending the push notification that will wake up the client. And now, practically, it's the route blocks that we add. Pushing in asynchronous mode, we will do it only when the target user is not registered. We'll call this function that will do the push, which was the previous route block. And if it's not failing in sending the push, then we suspend the transaction and we store it here in the hash table. We take the transaction index and label the internal identifier for the transaction. Now, when the registration was coming, practically we were calling this route block, and this route block it's here. So of course it has to be a register. If not, we go out. We check to see if we have information inside the hash table about this user, because you're storing on the user ID the information. We take the information from the hash table value and we say continue, where we have to give the name of the route, where to continue the processing. So practically we go to the location, and in location we should have now the contact of that target user. So this is how you can do it without a new module. It's just configuration file, scripting, combining a couple of modules. The only thing you have to add is this, how you send the push notification, how you interface. You may use a broker, you can send it directly to Apple, Google, whatsoever, if you have access to their API. Delegating to another instance system, practically, as probably most of you know, with Kamailio we have this event-based accounting, where for invite, for buy, we write the event to the database. So writing to the database is still blocking operation, and you don't want to get the busy routers doing that. As we are very good and very fast at SIP handling, why not sending via SIP? So practically all these routing nodes will send via SIP to a central node, which is still Kamailio, and this node will just write to the database the information that they got from the edge or SIP routing nodes. So this would be in the routing servers. We know that accounting happens when we have like a 200 OK. Of course, you need to adjust it a bit. It's just for the exemplifying. We can even create our own method. It doesn't have to be invite options or something standard. In Kamailio, you can have your own custom method. We will use here the UAC module. We say, okay, request accounting, some information that are mandatory in a SIP message like from, to, and other headers. And in the body, practically, we put the timestamp, the call ID from tag to match the dialog, and caller and callee, just a basic example in this case. What we'll have in the central accounting, so that the previous route had to be added in the default config file, let's say in this edge routers, SIP routing nodes. In the central node, this is the entire config that you have to do. Of course, loading some modules here because we need them, but in terms of action, the request route, we see it's an accounting. We can do another check on the target user, so it will be a store, and we will call like insert into accounting. We'll put here the column names and the values that we'll take here from the body of the message with some transformations. So then the SIP routing nodes, they will never block writing to the database. And another example to show combining MQ with RTimer for sending notification to Twitter when you have a missed call, which can take a lot of time because it's an HTTP query. This is actually a very old example, probably like 3 years. I wanted to put it back here because just to show this exists there for a long time. Just people don't need it, right? We are very fast at everything. So the idea is, okay, combining Lua, because we use a Twitter library from Lua, no need to write one from scratch in Kamailio, MQ for delegation to another process of this Twitter notification, RTimer spawning these workers, like Twitter notification workers, and SQL ops, we needed just to read the mapping between the SIP user ID and the Twitter user ID. And then practically this would be the config file for Kamailio with the modules loaded and config parameters set. This is the one that consumes the information from message queue. We named the message queue SIPWith. And then, as we have a result there, we'll look into the database to see if you have a Twitter user ID for the SIP user ID. If yes, we'll call a Lua function that will send the Twitter notification. In Kamailio configuration file, here it's adding into the message queue a missed call from the caller ID. In the main request route, after location, we don't find the user there. It has a missed call, and then we call this Twitter queue, which was actually just above, so it was just about adding to the queue. Here is the table that shows mapping between, Twitter user ID and SIP user ID, and this is very simple Lua script. So you have it as you load the Twitter library for Lua. All you need to do authorized with this open authentication token that you need to get from Twitter. It's a standard procedure, and the function that we call from Kamailio config file is seed tweet direct message with user ID and message that are passed by Kamailio, and the result will be visible on your Twitter client. So these are the examples I wanted to show quickly, but the framework can be used for other, like instead of sending a Twitter notification, you could do a database insert query, so you don't delegate to another Kamailio instance, you delegate to a Kamailio process. So yeah, it's more to discuss about this, but at least I wanted to give you the starting point, and we are available on the mailing list and discussing on some forums for further information if you need. So thank you, and questions after? Yes, I would like to thank again to all our sponsors, and especially helping with the Kamailio Award, and the speakers as well that came here, and all the person that participated here. You all together made this event very successful. And yeah, we are appreciating the feedback we took from the last year, trying to get a bit more into technical with some topics. So we had a workshop. If you have suggestions, what we have been done wrong, that's really important. But also we appreciate if we did something good, so we keep doing that. Otherwise we may change it because we may not know this time. So again, really thank you to everyone coming here, and I'm sure with many of you will meet meanwhile, but definitely you will have the third edition around here, maybe the same place, maybe a bigger place, a smaller place, a nicer place, southern, but probably Berlin is the first candidate also for the third edition. And I think it's a nice location in Europe, and good connection from everywhere. Thank you.